Hello, this is Dr. Mears, and today we are going to be learning about linear models, and this is in the course Applications and Interpretation SL1. A linear model has the general form of f of x equals mx plus c, where m is the gradient, which is the slope, and c is the y-intercept. A lot of times you're really used to seeing it written as y equals mx plus b. However, in IB, they like to write it as mx plus c. Same exact thing. M is still the slope. In IB, we call it the gradient, and C is still the y-intercept. The graph of a linear model is a straight line. The gradient is the rate of change of a function. This means as the independent variable, which is the x, increases, the dependent, which is the y, is either going to increase or decrease. And we're going to see that in an example in a minute. You will need to examine the graph or the sign of the gradient. An increasing rate of change has a positive gradient, and a decreasing rate of change has a negative. So here you will see that m is either going to be positive for increasing, or it's going to be negative for decreasing. Okay, let's put this into an example. Number 1, in a chemistry experiment, a liquid is heated and its temperature is observed. The graph shows the temperature of the liquid, T Celsius, T minutes after experiment starts, up to the end of the experiment. All right, what does that mean? They gave us a lot of T's here. So first, the capital T here, this is temperature. And it is in degrees Celsius. And it shows the temperature after the number of minutes, and that's our lowercase t. So on our x-axis, we have time in minutes. And on our y-axis, we have temperature in degrees Celsius. So please don't be confused by the capital T and the lower t. All right, let's just examine the graph before we actually start answering any of the questions. When examining the graph, we should notice the scale. On the t-axis, or time, we go 0, 2, 4, 6, 8, 10. So we're counting by twos here. On the t-axis, which is our y variable, we all of a sudden go from 0 to 80. Now, you will notice these little tiny lines. We're going to have to figure out what those little lines are, I'm sure. So let's look. I'm wondering if we count by tens. So we have 10, 20, 30, 40, 50, 60, 70, 80. And I am correct in my guess. If you're not correct, if it wasn't by tens, you might try 20s or 30s or even 5s. So I guessed that we counted by tens and I was right. So each one of these little lines in between is going by 10. Okay, part A. State the length of the experiment. So we want length. So we want overall, how long did this take us? So it started at 0, and where did it end? It ended here, so let's find out. That's at 10 minutes. Okay, next, estimate the initial temperature of the liquid. So since our experiment started here, we want to know what temperature did it start at. Well, we are counting by tens, so this is 10, and this point right here should be 20. So it started at 20 degrees Celsius. Okay, next, part C. Estimate the rate of change of the temperature of the liquid by first using the graph and then the gradient formula. Okay, so what we want to find is we want to find our slope, which is our gradient. So for the graph part, we're just going to look at the rise and the run. So we're just going to look at how we get from one point to another. So it's kind of like a map. Like, how do we go from point A to point B? Where do we go? So when we come back here, we want to know, how did I get from this start point all the way to this end point? Now, could I have chosen any point in between? Yes, but I think since we have the start point and the end point, it'll just be easier. So what did I have to do? How far up did I have to go? And then how far to the right did I have to go in order to get from this one point to this point right here? Okay, so let's examine that. So here we went from 20 and we went all the way up to 320. So we had to go up 300. So that is our rise. Our rise is 300. Okay. What is our run? How far right? So we started at 0 and we went all the way over, started at 0, went all the way over to 10. So we had to go right 10. So this is going to be 300 divided by 10. So we did the rise and we did the run. All right, let's divide that out. So we have 300 divided by 10, and that's going to give us 30. So that is the slope. By using the graph, it's 30. It's really 300 degrees Celsius for every 10 minutes. And when you do divide it out, this is really 30 over 1, so it's really 30 degrees Celsius for every 1 minute. That's really what it means, that rise over run. Now they asked us to use the gradient formula. So let's remember what the gradient formula is. M equals y2 minus y1 over x2 minus x1. So here we need 2 points. So the first point that we can use goes back to using that start point. So we have a start point that's right here. What is this start point? Let's label it. This is 0, 20. Okay. We also have an end point. This end point is going to be 10, 10, comma, 320. So we have our 2 points. So let's use those 2 points. So we have 0, 20, and we have 10, 320. Okay, so we have an x1, a y1, we have an x2, and a y2. Please be careful because a lot of students, what they do is they label these as x's. They're not. This is the first x, this is the first y. This is the second x, and it also has a second y. So let's substitute that into the formula. y2, 320. y1, 20, divided by x2, which is 10, minus x1, which is 0. And then we do the math. We subtract 320 minus 20, that's 300. 10 minus 0, which is going to be 10. And we find out that we're coming back to the same exact answer, which is going to reduce down to 30. Okay, next we have to suggest a formula to model the variable t in terms of t. So what does that mean? So that means t as a function of t. And this is how it's usually going to be. It's usually going to be capital T and lowercase t. Now you're also going to be having a number here, and that's going to be multiplied by t. And this number right here is going to be our slope or our gradient. Then we're also going to have a number here. And whether it's going to be added or subtracted is really going to depend on our y-intercept, that start point. So here we have m, so we find m and we substitute it in, 30. Here's our y-intercept. What is our y-intercept? Our y-intercept is that start point. It's that point on the y-axis that our graph crosses, which is right here. And so our y-intercept is 20. It's a positive 20, so we're going to erase this. Since it's positive, we know it's going to be plus 20. So our equation is t as a function of t equals 30t plus 20. Okay? Let's try this one more time. This is a conversion graph from pounds to kilograms. Part A is use the graph to convert 20 pounds into kilograms. So first, let's examine the graph. Here's pounds. Here's kilograms. What we want to do is we want to go to the 20 on the pounds. So we're going to go to 20, which is here on the pounds. And then we have to go up to the graph to see what our kilograms is. And then we need to make sure that we are going and having a good scale. So again, we have these tiny little lines. So we have to figure out what we're counting by. Let's try counting by ones. So we have 1, 2, 3, 4. And so when we count by ones, we end on 5. So I got it right. Again, if it doesn't work the first time, trying to see what those little lines equal, then you can always try, maybe count by 2s or maybe count by 4s. Okay, so we have 20 and then we go up and let's see. So I'm going to put the little numbers in, 6, 7, 8, 9. So I go up to 20 and then I go all the way over and I end at 9. So that's going to be 9 kilograms. I'm just going to put kg. Okay, part B. Find the gradient of this line by first using the graph and then the gradient formula. So again, first we're looking at rise over run. Where do we start? We start here at 0, 0. So how many do I have to count up? And then how many do I have to count right to get to this second point? You always need 2 points. They don't necessarily have to be the start and end, which you're going to find probably with one of your examples, but it does have to be 2 points. Okay, so how many did I go up? Well, I went up 9. And how many did I go right? Well, I went right 20. So I went up 9 and right 20, and we can divide that out to get 0.45. That's fine. Now our slope formula, I have y2 minus y1 over x2 minus x1. I need 2 points again, correct? Okay, so we can choose the start point, 0, 0. That's really nice when you have that 0, 0 point. It's not always going to be 0, 0, but it's nice. And then we can use this end point, which is 20, 9. Okay, x1, y1, x2, y2. Let's substitute it in. y2 minus y1 over x2 minus x1. Our m comes out to be the same, 9 over 20, which is 0.45. So we learned how to use the graph, and we learned how to use the formula. I bet you they're going to probably ask us for an equation. Part C. Find the model for F for K of X, where K is the number of kilograms, is X is the number of pounds. So we have K of X equals, all right, here we're going to need the slope, and then it's going to be whatever this is, it's going to be times that here. And then we're going to need the y-intercept. Okay, so our slope from back here we found, I'm just going to put the decimal point, 0.45. Okay, where is the y-intercept? So where does the graph cross the y-axis? It crosses right here at 0. So the y-intercept is going to be that y value, which is going to be plus 0. Okay, we have, now, if you have this plus 0, you could write this as K of X equals 0.45. A lot of people like doing that. That's fine. They leave the 0 out. Or if you like putting in that y-intercept, you can. All right, now we're going to use our model to convert pounds to kilograms and then kilograms to pounds. So they want us to bring this down, K of X equals 0.45x. And they want pounds, they give us pounds. Okay, so what is pounds? Pounds is X. See how it says X is number of pounds? So all we do is we substitute the 17 in. And then we get the calculator, and all we do is put 0.45 times 17. And that's 7.65. So 17 pounds is 7.65 kilograms. Okay, so this was a substitution problem because we were given the X. Now for this one, we need kilograms to pounds. So what they give us is they actually give us the output. This kilograms is this right here. It's our output. So we need to physically take all of that out and replace it with the number 25. And what this problem becomes is a solve problem because we were given the K of X. We were given the output. So since we were given the output, we now have to solve. We solve by dividing both sides by 0.45. And let's do this one last step. 25 divided by 0.45, and we're going to get 55 let's round it to 6 because we have that, let's round it to 6 because we have that 5 next, and that's 5 or higher. So it's really going to be 55.6 pounds. And that's how you use our equation. We were able to get slope, y-intercept, all of that good stuff with linear models. I'm hoping you remember this. You have learned it previously, and hopefully you're now able to do it. Hope it helps.